Today, we will simulate real-time performance monitoring of a call center. We will use Python to generate random calls from customers for our call center. We will create a Microsoft SQL Server database to store call center information for performance monitoring. We will fill the static information in the database using insert command. We will connect Python to SQL Server for automatic data entry. We will make changes in our Python code to generate most of the calls in the resolved category. Once the SQL Server database has been set up, we will connect it to the Power BI desktop application using direct query mode. After connecting SQL Server database to the Power BI desktop application, we will create a relational data model in Power BI desktop. Then we will create a Power BI dashboard to monitor the call center performance in real time. Finally, we will run this simulation in Python and test the results in real time in Power BI dashboard. In today's exercise, we will learn to work in Python, SQL Server, and Power BI, and to use them together to create stunning dashboards. If you do not want to use Python, you can also create a SQL query to generate same simulation from within SQL Server Management Studio. For that, see our video on sales simulation, published on March 5, 2023. In Python, we will import the datetime library to get the current date and time value. The time library to delay the time by 1 second during a loop. And the random library to generate random numbers. Now, we will create a never-ending loop to generate random calls. Let's declare a variable date to store the current date and time. Let's test the loop by printing the date variable. We will delay the loop by 1 second in every iteration. The loop is working great. Now we are ready to generate other random information. We will generate a random location ID between 111 to 201 using the random integer function. We have about 19 clients, with IDs from 11 to 30. We will use the company variable to store client ID. There are 19 predefined issues, regarding which a customer may call. A random issue ID will be stored in the issue variable, between 111 to 130. CSR variable will store the random generated ID of a customer service representative, between 111 and 210. The RTime variable will store the response time in seconds, between 1 second to 300 seconds. Similarly, the time spent on a call will be stored in the call time variable, between 1 to 600 seconds. There are 4 types of complaint status. A randomly generated complaint status ID will be stored in the status variable. On the basis of the complaint status, a random call rating will be generated between 1 to 10. Finally, we will print these variables in the console window to test the code. Let's run the code, to check if everything is working as it should, or not. It seemed that the board is working fine. We are successfully generating random calls after each second. In the next step, we will create a database for our call center real-time data. First, we will create a table to record the random generated calls data from simulation created in Python. We will save the table as calls. Next, we will create a table to store locations. We will create a table for our client companies, with their address and phone numbers. We will also store the information of our customer service representative in a table. Finally, we will create a table to store the status of the complaint. We will fill the static tables with the insert command manually. We already have data available in Microsoft Excel, which we will insert into SQL Server database using the insert command. We will use simple formulas in Microsoft Excel to construct insert commands from spreadsheet cells. You can also use other methods, such as import data from MS Excel, to fill the static tables using SQL Server Management Studio. Using the same technique, we will fill all the other tables quickly. Except the calls table, which will be filled by our Python simulation in real time. To connect the Power BI to the SQL Server, we will import the PyODBC library. Then we will create a PyODBC connection. We will choose SQL Server as PyODBC driver. Then we will provide the name of the SQL Server, which we can copy from SQL Server Management Studio. Next, we need to supply the database name, which is call center. And since the connection is local, therefore, it is a trusted connection. We will create a cursor, based on the ODBC connection we just created. There are a few errors in our Python code. The errors are in connection string. We should have used connect, instead of connection in line number 6. And we should not give any spaces, before or after the equal sign, in the connection string. Now the code should work fine without any errors. Next, instead of printing the variables, we will now use these variables in an insert command, to insert these variables into the SQL Server database. We will use the cursor.execute command, to execute the insert command. We will use the insert command, to insert the data into calls table. To get the current date and time in SQL Server, we will use the SQL getDate function, instead of the Python date variable. For all other columns, we will use the variables already created above. We are entering variables in the same sequence as columns are in our calls table. Finally, we will use the cursor.commit function, to finalize the insert query. Let's run the simulation in Python, and check the data in SQL Server Management Studio. If everything is working fine, the data should appear in SQL Server with a lag of 1 second. And just as expected, everything is working fine. Our simulation is working great, and it is communicating with the SQL Server just as desired. There are 4 types of customer complaints: resolved, referred, declined, and unresolved. Mostly, a call center resolves a large number of complaints. Some of them remain unresolved. Some of them are referred to a representative from the relevant company. And in some cases, customer's complaint cannot be entertained. However, in this simulation, all 4 types of complaints are equally proportionate. In this chapter, we will change the odds, in favor of resolved complaints. We want most of the complaints, to fall in the resolve category, and rated accordingly. Some of the calls, will then be classified, in other 3 categories, just as in real life. We have used an if-else statement for categorization, and 75% of complaints have been categorized as resolved. To test the changes in the code, we will first delete the existing data in Microsoft SQL Server database, and then run the simulation again in Python, and observe the data. If the code is working fine, the majority of complaints will come out as resolved. And as observed, our code is working just as we wanted. Most of the complaints are being classified as resolved, and the rest are being distributed among other categories. Now that we have created a simulation and SQL Server database, it is time to connect the SQL Server database to the Power BI desktop application. To connect Power BI desktop application to the SQL Server database, we need to provide the server name, and the name of the database. Both of them can be copied from SQL Server Management Studio. To display SQL Server data in real time, we must select the Direct Query as Data Connectivity mode, instead of Import option. We will select all tables from Navigator window, and load them into Power BI. Once these tables are loaded into Power BI Desktop, we will create a relational data model, which will be used in our performance monitoring dashboard. Now, we will go to the model view, and link all the tables to the calls table using relationships, creating a relational data model. Before we start connecting all the tables to the calls table, let's gather them in one place, for better view and easy access. By default, they are scattered all over the place, in the data view. We have ID columns in all tables, and their relevant ID columns in the calls table. We will connect all the ID columns to their relevant columns in the calls table. This is a simple drag-drop job, which does not require any technical knowledge. Just make sure that all the relevant columns are linked. And the columns that are linked have both same data type. Our relational data model has been created. Now, we can use this data to create a dashboard. Once the relational data model has been created, it's time to create a dashboard to display this data in real time. First, we will add a line and column chart to display call time, response time, and call rating by date and time. We will add the date field to the x-axis. The rating field goes to the line y-axis. The call time and the response time fields will go to the column y-axis. We also want to display maximum 30 data points at a time in the line and column chart. Therefore, in the filters area, we will select top N in the date field as filter type. Add the date field to the by value area. Enter top 30 in the show items area. And apply filter. We will also display calls by their geographic location. Therefore, we will add a map chart to our dashboard. We will add the location column from the locations table into the location area of the map chart. Let's change the style of the map chart to light. We will add the rating field from calls table to the bubble size area. Let's add a clustered column chart to our dashboard to display calls by their status. We will add the title field from the status table to the x-axis and rename it to status. and add any of the non-numeric fields to the y-axis as count, renamed as complaints. Now we will add a pie chart or a donut chart to our dashboard, to display number of complaints by the issue they pertain to. We will add the issue field, from the issues table, to the legend area of the dollar chart. And any of the non-numeric fields, as count, to the values area. We will rename it to complaints. We will make a copy of the donut chart, to display number of complaints, by customer service representatives. We will replace the issue field, in the legend area, with the CSR name, from the CSR table. We will add a gauge visual, to display average call rating, along with minimum and maximum value. We will add the call rating field, to the value area, as average, to the minimum value area, as minimum, and to the maximum value area, as maximum. We will change the title of the gauge visual, to rating. We will copy the gauge visual to display average response time. We will change the title of the gauge visual, to response time. We will make another copy of the gauge visual, to display the average call time. We will change the title of the gauge visual, to call time. On the response time gauge visual, we will replace all the rating fields, with the response time fields. On the call time gauge visual, we will replace all the rating fields, with the call time fields. Now that we have added all the visuals to our dashboard, let's create a title for our dashboard, using the text box visual. Finally, go to the page format settings, and turn on the refresh page option. Let's keep the page refresh option turned off for now. Let's first delete all the data from our SQL Server database. Now we will turn on the page refresh option, and set the page refresh rate, to 1 second. The data from the dashboard should disappear, as we have deleted all the data in the Microsoft SQL Server table. Now that Power BI is connected to the SQL Server in real time, which is connected to our Python simulation, let's start the simulation in Python, and come back to the Power BI dashboard to see the results. The simulation is working great. The data is being updated in Power BI, 1 record per second, just as we desired. Thanks for watching our video tutorial. We hope you liked and enjoyed our video. Don't forget to like and subscribe for more tutorials and updates.